All right, page 85 when we're done. So yesterday we reviewed the quadratic formula and sang it like champs, right? But I told you I can't guarantee that that's going to be on the exam. Maybe, maybe not. You're supposed to be proficient at it, so it's definitely possible. But I can guarantee you that stuff like this is going to be on the exam. Specifically, it could be in a multiple choice, but also on FRQ4. It will require students to solve various logarithm and exponential functions without the use of the calculator. Okay? So below are part of the directions students will see on this free response problem, along with 2 sample questions that could appear on one of the FRQs. So not saying that this is what the FRQ would look like, but this could be part of the FRQ. So the directions say, no calculators allowed. Determine the exact value of any expression that can be obtained without a calculator. For example, log base 2 of 8 can be written as 3. Combine terms using algebraic methods and rules for exponents where applicable. For example, all this stuff should be written in equivalent forms. So what I want you to do is take your paper, and the back is blank, but flip it upside down like as if something was on there. That way when you fold it, it is correct. And we are going to actually simplify all these little things so that you understand what exactly is being required of you. So the first thing that we are going to do is log base 2 of 8. Okay? And we're going to simplify it. There's 2 different ways we're going to simplify it. First way is we're going to set it equal to x and rewrite it as an exponential. Okay? So I could do 2 to the x power equals 8. Therefore, 2 to the x equals 2 to the what? Third. So x equals 3. Okay? So that's one way to do it, right? One of the ways that I have shown you how to do it. Now that we know more log properties, another way we could do it is to take log base 2 of 8, and then right here make that 8 into 2 to the 3rd power. So log base 2 of 2 to the 3rd power, right? And then what can I do with that exponent? Bring it out in front, right? So this would give me 3 times log base 2 of 2. And what is log base 2 of 2? 1. So that's 3 times 1, which is 3. Okay? So 2 totally separate ways to do it. They're both totally fine. It's good to know both because different things can come up at different times. Okay? We okay with that?
You have to show the exponents in the front.
You wouldn't have to. You could, so is your question, can you skip this step? Yeah, you could skip this step. It'd be fine. I'm afraid on your notes to skip too many steps. I don't want to lose anybody. But yeah, it would be okay. Be acceptable. Anything else? Alrighty, so then the next thing, and we're just going to do them all. The next one on there was 2x plus 3x. What is 2x plus 3x? 5x. It's not a trick question. But sometimes the simple things we do weird stuff on, right? All right, then the third one that they mention is 5 squared times 5 cubed. What does that give me? 5 to the what? To the 5th. Because when we multiply things with the same bases, we add the exponents, right? It is not 5 to the 6th, it is 5 to the 5th. Yes? Okay. Then we have x to the 5th divided by x squared. What does that give you? X to the 3rd. Okay, no difficult questions yet, right? All stuff we know how to do. And then the last one that they give us is, well, hang on. Natural log of 3 plus the natural log of 5. All right, so that's not like log base 2 of 2 where I can just say it's 1. That's not a value that you're going to know. But can you condense this to 1 log? Yes, this would be the natural log of what? 15. Okay. So that's what it means by equivalent forms or reducing it or whatever, combining your like terms type of things in all those different situations. All right, we good? All right, good. Flip it back over. So now we're going to take this one, and we're actually going to do this 2 different ways, just so that you can see that there are 2 different ways to handle it, again, for different reasons. This should say for values of x. It disappeared, and I put it back on more than one occasion, and it's still gone, so I don't know what happened to it. All right. We have f of x equals this function, and I want to solve for when f of x equals 1/2, e to the 1/2, for all values of x in the domain of f. Well, this is an exponential, so my domain is all real numbers, right? So I don't have to worry about that. But I'm going to take this, e to the x to the 5th power over e to the 1/4, and I'm going to set it equal to e to the 1/2 power. Okay. So just like any other equation, most of the time, as long as the fraction is isolated, then the next thing we want to do is get rid of that denominator, right? So I'm going to multiply both sides by e to the 1/4, so I'm going to get e to the x to the 5th power equals e to the 1/2 times e to the 1/4. Right. And could I make this on the left e to the 5x power? Yes, I just haven't, because I'm not sure if I want to yet, because there's different things that I could do with it. So there's nothing wrong with doing that, but again, you don't want to do too much in one step in case you wish you hadn't, and then you have to go back and undo it anyway. So we're going to leave this as e to the x to the 5th. And then what is e to the 1/2 times e to the 1/4? E to the 3/4. So now, at this point, could I drop the e's and just keep the exponents? Is that acceptable? Yes. So in this case, I do want to make it 5x, and I can do that when I drop them. So I get 5x equals, oh my gosh, what is wrong with my board? 5x equals what? 3/4. Okay. Then I'm going to need to divide by 5. Dividing by 5 is the same as multiplying by what? 1/5. So this would be x equals 3/4 times 1/5, which gives me 3/20. Okay. All right. Everybody okay with that? All right, so then we're going to look at a different process starting from here. I'm going to say this. So this would be or. So basically I could have gone straight down like I did, or I could have moved over here at this point. At this point, instead of dropping the e's, okay, which is a totally fine way to do it, but I want to show you another way just in case it's necessary, I could take the log of both sides. So I could take the natural log of e to the x to the 5th power, right? And that would equal, actually, let me do this. No, that's not what I wanted to do there. I'm sorry. Back it up. I want to get e to the x by itself. Sorry, went down the wrong road. I was like, that's not what I was trying to do. Instead of doing that, if I'm going to have e to the x to the 5th power, how do you undo a 5th power? To the 1/5 root. Okay, so I am going to rewrite this, which is what I was trying to do. Sorry. I'm operating on very, very little sleep today, so my brain's a little slower than usual. Okay, so I'm going to rewrite this. And then what I'm going to do to get rid of that 5th power, I'm going to take both sides to the 1/5 power. 1/5. Oh, why is that a 3? See, I told y'all, my brain, I don't even know where the 3 came from. Close enough. E3, they rhyme. Okay. Whew. All right, to the 1/5 power. All right, so let me pause to make sure that y'all are caught up since I was doing weird things. Everybody okay with everything I did at this point? To undo a 5th root, you take it to the 1/5 power, because then this is just going to be 1, right? So that leaves me e to the x over here equals e to the 3/20 over here. So once again, we could drop the e's, okay? But I'm also going to kind of show you why you're dropping the e's, I guess, just because it's another way to go about it. If I take the natural log of both sides now, I'm going to have the natural log of e to the x equals natural log of e to the 3 over 20. And then what happens, what can I do with my exponents? They do what? They come out in the front. So I'm going to get x times the natural log of e equals 3/20 times the natural log of e. And what is the natural log of e? 1. So x equals 3 over 20. Now, is the first way simpler? Yes. Even if you get to this point, you could still do it the first way. But there could be times where it comes up where you can't, kind of in the second one. So I wanted to show you the process at least once before we get to the next one. Okay, we okay with that? And because this is happening, notice, look at these 3 steps. So if I'm taking the natural log of e to some power, my rule is the powers get to come out front, then the natural log of e is 1, and so I just get the exponents left. So when I could go from here to here, all right? And that's again why you get to just kind of drop the exponents, drop the e's rather, all right? Everybody okay with all that? You get the same answer either way. All right, let's look at this next one and see why we can't do it exactly like the green way over here. So I have g of x, and I want to solve g of x equals 3e for all values of x. All right, so 8 times e to the 3x power minus e equals 3e. E means easy, right? It's an e in there, but just pretend like it's a different variable. It doesn't have to make it complicated. All right, now, on the left-hand side, can I combine those 2 terms? No, okay, because they're being subtracted and they don't have the same exponent on it. It's like x squared minus x. That is what it is. Can I move that e over to the right? Yes, I can do that. So 8 times e to the 3x power equals 4e. All right. And then I'm trying to get x by itself, right? So I'm going to divide both sides by 8, right? So I'll get e to the 3x equals 4e over 8. And then what's 4e over 8? How else can I write that? 1/2 e or e over 2, okay? And depending on how we write it might change what we do, and we are going to look at both ways, and I will tell you why when we get there. Let's go with e 1/2 times e first. So e to the 3x power equals 1/2 e. Okay. So now, I cannot just drop the e's because I have that 1/2 in there. Right? Like I did up there on the first one, I could have just dropped them because they were both isolated. But I have that 1/2 here, so that's a big fat no. So instead, I'm going to take the natural log of both sides. So natural log of e to the 3x power equals natural log of 1/2 e. Now, what is the left-hand side going to become? Just 3x, right? Because if we think about what's going to happen, we'd bring 3x out in the front. Natural log of e is 1, so it is okay just to jump down to 3x. Okay? Now, on the right-hand side, I'm not going to get 1, and I'm not going to get 1/2. I have a product right here. Can I use my product rule? It's my product rule. Exactly. Very good. So the natural log of 1/2 plus the natural log of e. Product rule, right? You can split it into 2 that are being added. All right, and then what's the natural log of e? 1. So I'm just going to mark that out and put a 1 there. So then I want to get x by itself. What am I going to do? Divide by 3. So x equals the natural log of 1/2 plus 1 over 3. Everybody okay with that? What questions you got? All right, so now we're going to go back and we're going to do it a different way, starting from right here, I guess. So from right here, oops, let's say or. So instead of putting 1/2 times e, let's say we did e to the 3x equals e over 2. Would y'all agree that that's the same thing, right? Okay, so now I'm also going to do the same thing as, so I'm there instead of here, but I'm still going to take the natural log of both sides. So I'm going to take the natural log of e to the 3x. You don't get to just put 3x there. Does that make sense? Like you have to show that you're actually taking the log. And that's equal to the natural log of e over 2. But the natural log of e to the 3x power is just going to give me what? 3x. And that's going to be equal to, so now instead of having a product, I have a quotient. So is that going to look different than what I did? It is, right? So this is going to give me the natural log of e, then what? Minus the natural log of 2, right? Because it's just whatever's in the denominator, not the 1/2, just the 2. Okay, what's the natural log of e? 1. Then I'm going to divide both sides by 3, so x is equal to 1 minus the natural log of 2 over 3. Now, when you look at our final two answers, doesn't look like we got the same thing, does it? But we did. And actually, the one in pink is a better answer than the one in purple. Now, if we did it the purple way, that's fine. We can actually finish it up to get it in this form. And you want to know that they're the same thing, because if this was a multiple choice question, which it also could be, you could have done all of this, gotten here, your answer's not incorrect. It's just not simplified all the way. Just like instead of saying log base 2 of 8, I should have said that it was 3, that type of thing. I shouldn't have a fraction in my log in there like that. Okay? So I could do a couple of things. I could split it as another quotient, but we don't need to go that crazy with it. Let's see how we could finish this one off. All right, where it kind of looks like we're done. But what's another way to write 1/2? 2 to what power? -1. So this can be x equals the natural log of 2 to the -1 power plus 1 over 3. Yes? Then what happens with that -1? Goes out in front, so that would equal negative natural log of 2 plus 1 over 3. And then if you flip that around in the numerator, that's what you get. And that's why they're the same thing. It's like magic. I'm going to go with yes. I've been digging. I was looking for actual evidence that says we have to have it as whole numbers and not fractions. That is what I'm leaning to, truly believing is the expectation. I feel like I've seen that in writing somewhere already. I'm just can't go back, can't find it when I'm going back to look at it. So I'm going to go with yes. That's the fully, and I was actually just talking to Mr. Ackerman about it, saying like, when you talk about fully simplified, like is this fully simplified or is this fully simplified? Well, in calculus, this is fine because we're not testing whether or not you can manipulate logs. But in pre-cal, we are testing whether or not you can manipulate logs, right? So that kind of changes the whole idea of things. So I'm going to go with yes right now. We're going to practice it that way. If I find out differently, I will make sure and let you know. Okay, we all good on that? Any questions? Okay. And again, if you end up with it, you don't have to freak out. You just have to know what to do with it to get it there, and you'll be fine. Okay? Any questions? All right, good deal.